Hi, welcome again. So, as we did in the previous video, what we did, we find the supports everywhere. Where we have the supports here in AY. This have two components, and here we also have BX and BY. So we find all supports. Then what we do, we just add all forces, and then all supports is equal to 103. So it means our supports are okay. What we will do now, we just we will now make the shear force diagram, which is this AY is going up, the load is coming down, and here no loads here, and also this 70, which this is. So this is the 70 is also here you can see going down, and we have moment here, and BY is going up. So now what we will do, we will just find the shear and moment everywhere. Now let's see here in the next slides what I did it. Because of AY is going up, you can see here AY is going up, so in the shear force diagram AY will be going up, and here we have no load, so it will be straight, and then the loads will be down. But this load is like a 3D line, which is like 3 degree. So what we did, we can't solve this one just like going straight downward, so we have to cut the beams here to understand the shear force, how the shear forces react. But you can cut your this load area for the moment as well. But you can see here what I did, I just cut here. We don't have this load before, so I didn't cut here. You can just draw it directly, but after this force or at the mid of the force you can cut it. I cut one times after the load, so here I cut, and then the AY is going up, which is 52.79 AY, but multiply by degrees, so we can find the AY. AY 45.7 is going up, and then there is no load, so then the 4 kilonewton per meter multiplied by the distance and divided by 2, which is 5. So pipe is going downward, and what we have, nothing, V. So we can find V here from this one, which is like, let me take the pen. Here you can see, yes, here 21.4. This one is the support, 26, and pipe 1 is going downward from this UL force. Now we can find the neutral axis, which is like N is going right, and also the force is going right, so it will be like in another side, and answer is 45.7. Now what we will do, we have to find this M. This is the important things. You can't even find just from the area of the shear. You have to cut the beams here and find this moment. So now the moment is going this side, because this is the rule. If you cut from the left side, this will be going up. So now we have positive M, then 5 kilonewton here, which is the center of gravity of this force is here, which is 1 over 3. So this is the 1 over 3, but I will take moment this point to this load, so I have to note I need this distance, which is 1.66, and you can see here 1.66. Let me find as well. 1.66, which is 2.5 minus 0.83, which is 1.66 here. So here you can see the another force, which is the supports going up, so it's negative, and we have find 140. This is the moment at this distance. So you can see here we don't have others EUL or EUDL forces, so this is directly points going down, and then this will be negative, and the support is going up. So you can see here in the shear force diagram, this is the shear force diagram. What I said that this is 0 points, which is support, then AY is going up, which is 52.79 multiplied by cos of 30. This is this. This is going up. There is no pause. So, sorry, this is straight. Okay. Then what we have? We have 5 kilonewtons total load in 2.5. So it will be going slowly until to -5. So from this 45 minus 5, this is the 40.7. There is also no load, so it will be going straight, and this loads will become here as well. Now what we will do, we have to find the point load which is going downward. So what was the force? The force was 70. So 70 multiplied by 4 over 5, which is 0.8. So it's like totally 58. 56. So 56 is going downward. So if 56 is going downward, minus 40.7. So this will be 15.28. This is 16.28. So I just made a mistake here. This 15.28 is going negative. It's negative 15.7, and there is also no force, so it will be straight. And here we have supports, which is by. So by was also 15.28 positive, so it's going up, and here is 0. This is the shear force diagram. What I did now with the moment diagram, I just did from this area. I find the moment diagram from this area. This is the one method which you can find your moment diagram by area or by cutting. Any method you can use. It's easy. So what I did, I have area here. Okay, I have this area. What is the area? The area is rectangle. So 45.7 multiplied by 0.7. So this is the value. If the shear force is positive, the moment diagram also be going to positive. So we have 34.26 from this area. What's next? We cut already before, and we have find 140.22 at this. I can't find this area by a simple rule. You just do like this. And how to find this area, which is like this needs to be take integration and other stuff, so I can't do this. So for that purpose, I cut the beam here. In before slide here you can see here, and I find moment 140. Okay, so what's next? I find 140. What's the next? The next is simple. Just again the rectangle area, which is 40 multiplied by 2 meter. 40 multiplied by 40.227 multiplied by 2, which is 81.22. So what I did, just add them at 140. Because of the area, this one area is also positive, so the moment is also positive, and the next area is also positive. So just add them and find your next moment value. What is the next moment value? Here you can see 221. 221, and then we have negative, so the diagram will be going downward, and the negative is what? 15.28 multiplied by 1.75. What is the value? You can write here. I didn't find it, didn't find as well. So 15.28 multiplied by 1.75, which is 26.7, and 221 minus answer, which is 194. So here I have 194, and also I have moment here, which is fixed, is going to be 0. So this is the procedure for to find the shear force and bending moment diagram. If you have EUL force, so you can just cut the beam and draw it. And if you don't have EUL force, just draw it by area. So it will be easy. It will not be take your time and calculation stuff, etc. So this is the full projects which is presented by a teacher in statics. So this in, and you can find just add your row number and solve it easily.